Hello, welcome back, everyone. In this session, we're going to explore the essential tools that we are going to use to build our heart disease machine learning prediction model. These tools will enable us to successfully build, train, and test our model, ensuring that it can make accurate prediction based on the medical data that we are going to feed it. We'll walk through the different stages of machine learning workflow from data processing to model evaluation and discuss the specific tools that will help us at each stage. Google Colab. Google Colab is an excellent uh, cloud platform for everyone working on data science or machine learning or any scientific computing. It's powerful and combination of free computing resources, real-time collaboration, and cloud-based access to data, which makes it efficient tool for both beginners and professionals. Whether you're learning, collaborating, or conducting high performance computational tasks, Google Colab is a great solution for you. Why we have to go with Google Colab? It's cloud based Jupyter notebook. It provides a free cloud environment to write and execute Python code, making it perfect for machine learning tasks. It also provides you a free GPU and TPUs for speeding up your machine learning training processes. Colab also comes with a popular Python libraries pre-installed already, so which make it easier to start without worrying about any libraries or installations. Programming language, which Python is the most popular language for machine learning because of its simplicity and rich ecosystem of machine learning libraries and its endless support community. Google Colab comes with, let's say, a pre-built Python and data pre-processing libraries, including Pandas. Pandas is a library which is used for data manipulation, cleaning, and analysis. Also, NumPy. It's a library that is used for numerical operation and working with arrays. Moreover, when you want to do some data visualization tasks, you go with Matplotlib and Seaborn. Also, we are going to use some of the machine learning libraries, including Scikit-learn, which is used for machine learning algorithms and model evaluation and data processing. When we are going to evaluate our model, we are going to use some libraries and tools, including cross-validation and grid search CV. So these are the key tools that we are going to use to implement our heart disease prediction model using machine learning. So stay tuned for the next step so we can use Google Colab to start building our model. So here are the key summary steps that we're going to go through, and I'll explain each of these steps with its codes and with its tasks and functions so we can understand how we can accomplish these main tasks. We'll start by importing the required libraries. As we mentioned before, there are some several libraries are required to start building and pre-processing the data and learn and then training our models. So these libraries include like Pandas, NumPy, Matplotlib for visualization, and Seaborn and Scikit-learn for machine learning libraries. Next, we are going to load the data set that we are going to use. We'll upload it as an Excel sheet to Google Colab. Next, we'll do perform EDA to visualize the data and understand its structure and check in case if there's any missing values or outliners and understand the relationship between the variables. After that, we will pre-process the data to handle the missing values or encode the categorical features and scale the features if necessary. After we process our data, we will train and test split. So we will split our data into training part with 80% and the testing split with 20% using train test split from Scikit-learn library functions. After we split our data, we have to start with training the model. As we mentioned that we have to choose the model that we are going to train our data based on using logistic regression or random forest. So we will feed it the training data that we have split on the previous step. After that, we'll move to evaluate the model. We'll assess the model performance using metrics like accuracy, confusion matrix, and ROC AUC curve. After we see the results, we will go with the hyperparameter tuning as part of the model improvement. We'll use some functions called the grid search or random search to optimize the model hyperparameters to find the best parameters that the model can perform in order to enhance the model performance. Final model evaluation will include testing our final model in the testing data which we have separated to ensure that our model will be evaluated based on unseen data. Lastly, we will save and deploy the model. To start with the first step here, when we have to identify the problem. In our case, so what we are trying to do is we're trying to build a heart disease prediction machine learning model. So the problem definition here is, as you know, that heart disease is one of the leading causes of death worldwide. Making early diagnosis and prevention is critical. With machine learning, we can build a model that helps doctor and healthcare professionals to make more informed decisions, potentially saving lives and improving the patient care. Giving clinical parameters about a patient, that means the data that we're going to feed the model with, we can predict whether or not they have heart disease or they are risk at having a heart disease based on the data and parameters that each patient have. So the objective here, the objective or the goal here to predict whether a patient has heart disease based on different various health attributes such as age, gender, blood pressure, cholesterol level, and also other clinical features that the data is going to be fed with. It's a classification problem where the output will be binary label. Binary label means it's yes or no or one or zero. One include indicating the presence of a heart disease, or zero indicating no heart disease. As we mentioned here, the type of problem here we identified as classification, since we are trying to predict a target variable, one or zero, which yes or no. The measurable goals that we have here is to evaluate the effectiveness of the heart disease prediction model. We will use several performance metrics, including the accuracy, precision, recall, and F1 score. The accuracy is the percentage of correct prediction, which is both true positive and true negatives. The goal that the hospital has set to us is achieve an accuracy of at least 85%. The next metric that we are going to measure our performance based on is precision, which is the proportion of positive prediction that we're actually correct. This is critical in healthcare since we want to minimize the false positive. The goal set on precision is to achieve at least 80%. Next, we have the recall, which is the sensitivity metric. It's the proportion of actual positive cases correctly identified by the model. We will see in more example what are the positive and what are the negative cases later on. This is important in healthcare as we want to ensure that as many heart disease cases as possible are detected, even at a risk of false positive. So the goal set here is to achieve at least 90% on recall or higher to minimize the chances of missing any heart disease cases. The last metric here is we have is F1 score. F1 score is the mean of precision and recall. It balances the trade-off between precision and recall, providing more nuanced evaluation when both false positive and false negatives matter. The goal here as set is to achieve 85% or more. So as we have completed the first step, identifying the problem, setting the objective, and setting also measurable goals, we can kick off and to go to the data step now.